section 9.1, the Pythagorean theorem and its converse. We've discussed the Pythagorean theorem this year. We learned that when we have a right triangle, the hypotenuse points to the right angle points to the hypotenuse, and that's our C value, and the other two sides, the legs, are the A and the B. And we learned it is A squared plus B squared equals C squared. With the introduction of using the converse, I'm actually going to start setting up my equations by putting C squared first. And I'm going to get in the habit of making sure C squared goes first, so that way when I'm solving with the converse, it's set up for me in the way that's going to be most beneficial. The Pythagorean triple is a set of three positive integers that satisfy that equation. So there are very common Pythagorean triples like 3, 4, and 5. If I plug them into C squared equals A squared plus B squared, where C is the biggest number, that'll work. Same with 5, 12, and 13, 8, 15, 17, 7, 24, 25. And they've also listed the multiples of those, because if I doubled 3, 4, and 5, 6, 8, 10, that's still a Pythagorean triple. It'll still work to make a right triangle. There are many, many, many other Pythagorean triples. We just didn't list them here because that would take forever. So for the first examples, we're going to find the value of x and then tell whether the sides form a Pythagorean triple. Essentially, for this part, we're asking, are all three sides whole numbers? That's what they're asking. So in this problem, it's possible that we have a triple because so far the first two sides are whole numbers. I'm going to use my right angle to determine what side is C, and I'm going to plug it in to C squared equals A squared plus B squared. So that's going to be x squared equals 8 squared plus 13 squared, or 13 squared plus 8 squared. So we could do this all on the calculator at once, or you could put it in separately. You could do 8 squared and then 13 squared and then add them up. Or on the calculator, 8 squared plus 13 squared is 233. And my last step is I want to take the square root of both sides when I want to get x. So taking the square root of 233, I get 15.3. So that's a decimal, which means all three sides were not whole numbers. So my answer is no, they are not a Pythagorean triple. All right, example 1b. I'm going to use my right angle to determine C. So I got 5 as my C, so that's going to be 5 squared equals, the other two sides are x squared and 3 squared. I can't put this all in my calculator at once because we have the x and the 3 on the same side. So we'll do 5 squared is 25 equals x squared plus 3 squared is 9. We'll take away 9 from both sides. So 16 is equal to x squared. We'll take the square root of both sides, and we get x is 4. So my sides were 4, 3, and 5. Those are all whole numbers. So for the Pythagorean triple, that answer would be yes. So here's 2 for you to try. Answers are posted on Google Classroom. You could pause now if you'd like. For example 2, this is a much more complicated problem. We want to find the whole length of x here, but there's no right angle here. The big triangle is not a right triangle. So I'm going to start by working on just this triangle. And I'm going to find side A, right? That's C, that's B. So I'm going to find side A. And we can call it a new variable. You can call it the letter A. I'm going to call it Y, just to give it a different variable than X, and so I don't confuse myself with the A, B, and C. So we know that side C, so that side's the one that goes by itself. 29 squared equals 12 squared plus Y squared. 29 squared is 841 equals 12 squared is 144 plus Y squared. When I take the 144 away from 841, we get 697 equals Y squared. Now, if I wanted to use this problem, this number, right, because I'm going to take the square root of both sides. If I wanted to use this number in a new problem, I would have left it as the square root of 697, but because I'm going to actually end up adding it to something else, I want the decimal, so I'm going to get 26.4 for Y. I have a totally different right triangle on the other side. Let's say this side is Z. So here was my right angle. Across on the right angle is my C. So 14 is C. So 14 squared equals 12 squared plus Z squared. So we're going to get 196 equals 144 plus Z squared. Take away that 144. We have 52 equals z squared. Take the square root of both sides, and we get 7.2. So this little piece here is 7.2. This bigger piece here was 26.4. Together, they were x. So x will equal 7.2 plus 26.4. So that's a total of 33.6 for x. So it's possible that we'll need to use multiple triangles in a picture. It's possible in the instance of your check-in that you'll have to find a side in one, find this side, and then use this side as a whole new side in a new triangle. For this one, I would recommend leaving it as the square root. And just a little tip, if you have something like the square root of 15 and you want to square it, the symbol and the power cancel out, so that just equals 15. So that's why we leave it as the square root, because we're going to get it, put it squared into another problem, and it's just easier to do that. So here's a check-in. You can pause now if you'd like. The answer is posted on Google Classroom. So for example 3, a roofer leaned a 16-foot ladder against a house. So we have a 16-foot ladder leaning against a house. The base of the ladder, here's the bottom of the ladder, is 5 feet from the house. So 5 feet from the house would be here. How high up the house does the ladder reach? So we're looking for this distance here. We're looking for that side of the triangle. So using my right angle, that's c. So I would do 16 squared equals x squared plus 5 squared. So that's going to be 256 equals x squared plus 25. Take 25 away from both sides, so 231 equals x squared. And now we'll take the square root, and we get 15.2 feet. So here's a check-in. Pause now if you'd like. The answer is posted on Google Classroom. So now we're going to learn about the converse. So the converse is what we can use to tell if a triangle is a right triangle. So if c squared is equal to a squared plus b squared, then the triangle is right. So it has to be equal. If it's a different symbol in between, it's going to be a different kind of triangle, and we'll talk about those in a bit. So right now we're just checking if c squared is equal to a squared plus b squared, we can call it a right triangle. So for example, for A, determine whether the sides of the triangle would form a right triangle. The biggest side has to qualify as C, so in this problem, 5 would be my C. So we're going to check 5 squared is something to 3 squared plus 4 squared. So 25 is something to 9 plus 16. 25 is something to 25. So these are in fact equal, so the answer would be yes, it did form a right triangle. As long as it's equal, the answer is yes. Example 4b, so my biggest side is 9. So we're going to check 9 squared is something to 4 squared plus 7 squared. So 81. Just like before, you could actually do 4 squared plus 7 squared together on your calculator. We get 65. So this is not equal. So this would be a no. It did not make a right triangle. This would form either an acute triangle or an obtuse triangle. Example 4c. If I want to know which side is C, I should take the square root of 113, and this is about 10.6. So this is the biggest side. I'm not going to use the 10.6. I just used it to figure out that that is my C side. So that's going to be the square root of 113 squared is something to the other two sides, 8 squared plus 7 squared. Just like I told you before, when you have the square root of something being squared, those cancel. So this is just 113. And on the other side, we have 8 squared plus 7 squared, which is 113. So those are equal. That would be yes, it is a right triangle. All right, last example together. So this one's even trickier. 4 square root of 95 is about 38.98, so it's about 39, which is bigger than 36 and 15. So this side is my C. So that's going to be 4 root 95 squared is something to 36 squared plus 15 squared. This side is much easier to do. 36 squared plus 15 squared is 1521. But on the other side, I now have a number and a square root being squared. The number squared, 4 squared, is 16. And the square root of 95 squared is that 95. That canceled. So really this side is 16 times 95. So that's 1520. So those are not equal. This is not a right triangle. For these problems that we said were not right triangles, we will be able to tell if they're acute or obtuse, and that'll come up next. All right, first there's a check-in here for you to try. You could pause, answers posted on Google Classroom. All right, now the final part of the converse, how to tell what kind it is. So if c squared is less than a squared plus b squared, that makes it an acute triangle. And if c squared is greater than a squared plus b squared, that's when it's an obtuse triangle. And we know acute angles are less than 90 and obtuse angles are greater than 90. So as long as we put our c squared first, the symbol should make sense to the type of triangle we're saying it is. So for example, 5a, my biggest side is 18, so that's my c. So I'm going to do 18 squared is something to 11 squared plus 14 squared. So 18 squared was 324. 11 squared plus 14 squared is 317. So 324 is bigger than 317. So greater than makes it an obtuse triangle. Example 5b, my biggest side is 11. So we're going to do 11 squared is something to 9 squared plus 10 squared. So 11 squared is 121. 9 squared plus 10 squared is 181. So we have less than. 121 is smaller than 181, so that would make it an acute triangle. So here's our final check-ins. You can either pause or end the video. Answers are posted on Google Classroom. But that is the Pythagorean theorem and its converse.